Hello and good morning. This is Carsten Bott speaking from EMC in Germany. I just finished a pretty awesome webcast for PowerShell.org with Hal Rottenberg and John Waltz. Within that webcast, we discussed EMC Storage Integrator. To get an understanding to the people what EMC Storage Integrator is about and what it means for PowerShell, I just decided to take a short video of what we are able to do with the EMC Storage Integrator. So we talked about silos between applications and storage systems and storage administrators. This is something where EMC Storage Integrator tries to build bridges between all those silos. As you can see here, we have a management interface that's a Microsoft MMC, where we have all our various storage systems. Like here is a VMAX storage system, and you see the notation. You have storage pools and LUNs and masking views and service nodes. So typical to an EMC storage system, we have pools of drives or drive technologies. Out of those pools we build LUNs, and the LUNs are those elements that we map to hosts via LUN masking views or storage groups, so that hosts can see those LUNs in those various masking views, and the hosts can access the storage systems via ports or something that we call service nodes. So imagine a large system like a VMAX could have plenty of directors with fiber channel or different types of connection options to connect to. The same applies to a VNX system, which is the mid-range to enterprise system. We have storage pools here as well. We have LUNs. We have hosts that we can register, and other than masking views, we have something called storage groups and service nodes. Then we also can connect to the hosts, and we do this with Windows remote management, with WMI, with some remote services for virtual disk service. This is where we actually can go out to a remote host with our Windows credentials and retrieve information about drives and disks and SAN initiators. This takes a while because he has plenty amount of drives. We see the fiber channel adapters that he has inside. Eventually network connected drives, and those are my physical drives. And what you can see here, it's like people are looking out of the window. What do they see? A storage admin sees different things than a Windows admin does see. So a Windows admin will see his physical drive 10. It's MBR GPT formatted. It has a capacity and a mount path. What we bring to this system right now is which storage system this LUN is sitting on, what's the LUN name, what ID on the storage, and what LUN identifier this thing has, and mount path, host volume identifier, the size, the allocation unit, and the label. So everything, how the operating system is seeing those drives to how the storage admin is seeing those drives, we are showing here. And we are showing also the view of a cluster system, because to a cluster system within Windows, a hard drive is something different than a cluster disk. So we can see the cluster nodes belonging to it, and we can also connect to those cluster nodes pretty easy from here. With our Windows credentials, we test the connection. Yes, it's possible, and we add it so we can manage each individual cluster node, and we can add the other one as well, so that we can dive into each individual host. So while he's still refreshing the cluster disks, I must leave a word on why is he doing this. So we are not storing actually information. Once we first get into the system, we're refreshing the drives, and we are refreshing the disks, because those things can change. We are not storing anything here locally other than the configuration. So which host are you connected to, with what credentials. We can store these information in your local PowerShell session for your local user, or we can store this information in Active Directory. So each system you're connected to gets stored in Active Directory for your user. Other than we can connect to hosts, we can also connect to hypervisors. Like this is our VMware environment, like our vBlock with 3 blades in it, and we see the whole cluster that we have in that vBlock with all his systems, with all the data stores, and with all the virtual machines sitting in here. So those are virtual machines sitting on VMware, and we can drive into each application and see what virtual drive it's using and which data store it's on and all that stuff. And we can also drag into each cluster node and get information on the cluster nodes. This is completely MMC driven, but it uses our .NET methods that we have deployed that we are also using within PowerShell. And we also can have a view on Hyper-V. So this is my Hyper-V system. We can see the host drives as well as in a standard Windows system, but since this is a Hyper-V host object, we also can see the virtual machines sitting on that environment. As I mentioned in the call, we have also other things like Exchange applications, so we can integrate into Exchange, see the mailbox stores, see the mailbox databases, and we can also do the mapping to the disks in the storage array here. We can do it for SQL, and we can do it for replication systems, like our recover point, just to build a remote replication of what we call consistency groups, put drives into a consistency group and replicate it to a remote site. Like here, this is for a site recovery manager within VMware. It gets visible into here. And the last thing that we have is integration into our what we call AppSync. AppSync is our application consisted snapshotting and continuous data processing. So for each and every database that we have here, we are building copies, snapshot copies based on a service plan, and we do it, for instance, here with a VNX snap, and this gets moved out, gets stored on a snap, and we see what storage is connected. So in this AppSync system, we are using the same storage that we have here, and we are also connecting to, let's say, recover point systems to have a remote data protection, and we can switch the view here from protection to service plans. That's all possible. Well, that's enough on the UI portion of it. There's also a good amount of PowerShell that we can do with it. So this was for the protection view, and we also have a view on the service plans. Service plans are essentially defining what type of replication we need to do for a database. If it's a local snapshot every 24 hours, a remote replication, whatever it is. And we subscribe essentially databases or service or database availability groups to a service plan, and you see those snapshots created here. And this is here the bronze snapshot. It runs every 24 hours, and we keep 7 snapshots. And that's essentially what we are doing, and these are the events. So when did those snapshots happen, and we track it down every year. Application discovery, creating snapshots, error occurred if something goes bad, so everything is tracked down here. Now that's the MMC portion, the MMC piece. Since this is the PowerShell.org community, we want to show what we are doing here with PowerShell. So I'm just firing up my MMC, my ISE. So this is my Windows PowerShell ISE, and to get started with, our module is called esipstoolkit. So you can do a get command minus module esipstoolkit. Off we go, and here you see all those commands that we have in here. So it must be around 150 something. Let me have a look. Measure object with measure object. 225 commands do we have right now. So it's getting constantly more and more. So we're getting better and better with it. In the webcast, we talked about the basic functionality. What can we do? How can we provision a LAN to a host? So first of all, we need to get some information on our storage system. First, I'm defining some constants here, like my storage system I'm talking to and the host I'm working with right now, because I'm a little bit silly and I don't want to type that information in. And the pool ID is pool.0, and that's the standard pool that I want to use. I'm just making this constant for me. So the first thing I need to do is get information of my storage system. So I do a dollar storage system is get emc storage system. Well, a lot of stuff here. Storage system for my storage name, and let's run this. I deleted this by accident, I guess. And once we are finished with it, I do a dollar storage system, and we have the information of our storage system. As I mentioned earlier, we don't store information. So what we have right now is the basic information of that storage system that we have refreshed in the system here, which is the IP address, the connection type that it supports for hosts, it's iSCSI and fiber channel and all that stuff. Nothing in for LUNs. What we can do right now with dollar storage system, we have some refresh methods, and we can, let's say, refresh drives. So it refreshes all the disks. We can do a refresh LUNs or a refresh all. So depending how big the array is, this may take some time, but then those entities get filled in storage systems. So if we look in storage systems, we refreshed all the disks, and thus we also refreshed the enclosures. So if we do a dollar storage system, we see the amount of drives that we have in our system, and we also can list those drives. Beware, there are empty drive slots, so we have to look for those drive slots that are not empty. So it's 66 drives that we have currently in, and we get information like vendor and all that stuff. This is just showing you how that works. So right now we have a storage system. The same applies to a host system, so we can get an EMC host system. And if we look at the host system, it's the same. We see all the information of the host system. Host disks are not refreshed. Other properties are not in. Host bus adapters are not in, and we can refresh this those methods by just using the refresh method. And I'm going to use a refresh all. That refreshes the whole host system. Now, what's interesting here, if we do the refresh host system, he actively goes out to the host and refreshes stuff like multipass emulations, multipass information, the drive mappings, because we emulate drive mappings when we use MPIO or PowerPass. So this information needs to be reverted and needs to translate it to no, I'm hanging. Needs to get translated to the original physical drives. Since this is a hypervisor, we also get the VM information like MAC addresses and all that stuff of all our virtual machines. So once this is back, we can continue with our work. We have different host system types, so right now he's refreshing the complete host system. We could also connect only to the host system type of Windows in here. Now, as you can see, for this host we are also refreshing stuff like SCSI controllers and disks connected to SCSI controllers. If we go back to the MMC and go to one of those agent hosts, and we go to the hypervisor portion of it, you can see exactly the same information in here. What virtual disks is he using? Like here it is little SCSI disks with an ISO image and the VHDX files that this one is using. Also, this REE disk, REE host, is using some SCSI controller drives in here. So everything just reported to that system. So once we have all that refreshed, got this information in here, we got the host disks, we got the physical drives. We do the same for the pool. We want to get the pool with the pool ID. If I go to $pool and say show me the pool, it tells me okay, it's a pool on VNX array. It's called VNX 5300C 185 demo pool 0. It's a mixed type, so we have all types of drive in there. We have a total capacity of 18 terabytes, and subscribed are 22 terabytes, so we can do thin provisioning in here. This is the pool we are going to provision from. When we want to build a new LUN, we just say new EMC LUN minus pool $pool. The name of the LUN, I just name it test1 in here, and the capacity of that LUN. And it's going to create the new LUN on the array. Hopefully nobody else has built a LUN test1, because otherwise it tells me that name is already given. And it's just a process of a few seconds, and then we are coming back with a new LUN. So the process of creating a new LUN is the same for if it's a VMAX system or a VNX system. It's just the command new EMC LUN, and you are done with creating a new LUN. Just have to make sure that PowerShell, that the ISE is not frozen, because I'm using a remote desktop to the company, and if the SYN client gets frozen, I don't see the task to be completed. So I put the result into a variable that's called LUN. So if I look at $LUN, this is the LUN I just created. I see it's created in pool 0 like expected. I have the worldwide name. This is normally the information that you have to search for in the Windows host. The name is test1, it's 100 gigs, and it's not a private thing, and it's mapped to an SP and all that stuff. Now I want to have my host being able to see that LUN, and I need to set a LUN access. This is exactly what I do with set EMC LUN access. I give it the LUN, I give it the host system, and I set the visibility to available, so that this LUN is available to the host. And just I do this, and he's doing something that we call unmasking in storage. So we look for the host. If he's registered at the array, which storage ports is he using, and we make this LUN visible at those storage ports, so that then later on we can search that LUN in the Windows host. And that's what he's doing. He's adding the LUN 23 that he has created over here to a storage group called agentj.lsc.mux with host LUN ID 16, so it's the LUN 16 to the operating system from the SCSI controller, not the hard disk. And what we need to do right now is we have to find this host disk within Windows. Well, there's a cool command that was in EMC that's called find EMC host disk, that we are going to execute once my session is back. So to set the EMC LUN access, I run this set EMC LUN access command, and after this I search the host with find EMC host disk. Just execute it. Now he's going to rescan the disks on the host, so he's actually going to the host and is doing something that you normally would refer to disk part rescan or whatever it is. He's getting right now the information of all the drives that we have, all the new drives that have arrived. So he's doing some plug and play stuff internally, and once he has identified the drive, he's filling the variable $host disk, and we can look at the $host disk. So this is the drive, it's physical drive 22. There's no grid on it right now, it's unallocated and it's offline. So what we normally need to do right now is we set the drive online and put a partition table on it, and we do this with initialize emc host disk that does everything for it. Try to do the same with Windows commands. When you're on 2012 and especially R2, you will find some new commands that do it, but prior to that, this part was your best friend. So we do initialize emc host disk with a partition style of GPT. And he's doing everything for us, and then we just build a new volume. Would be funny to see if we look at $host disk, what this will show us. It still says offline because it has not refreshed that information, but if we do it again, it will be completely different. So now we do a new EMC volume, which creates just a new volume, formats the drive, and then the volume is provisioned and mounted. And the mount actually is done with that EMC volume mount point, and you specify a mount path. For people who don't want to specify a mount path and use a old-fashioned drive letters, there's a command that's called find EMC available drive letters. I will show you later on. We now set just a volume mount point with ctest LUN1, and then the provisioning is done. So, and this volume has successfully mounted. We can now flip over to Agent J, just to prove that we are right. I'll flip over to my Agent J. Go to the C drive and look if there's a test LUN1. Off we go. That's the one we just created at 524. This is our test LUN1. Yeah, okay. Here's something, if you do want to do that stuff like identifying worldwide names and all that stuff and not using our PowerShell commands, you can do something silly like this. This is what I just currently was doing for a customer that asked me for it. How do I get this information out of VMI, worldwide names, worldwide node names, port names of fiber channel adapters? If you're interested on that stuff, just look in my blog and I have that stuff in here. Let's see if we can find the host disk again and do a $host disk. A refresh would also have been good. Is unallocated is right now set to false, and you have all that information in here. So whenever something comes, we can find those host drives. I told you about another command. It's get EMC available drive letter minus host system $host system. Wow, those are the available drive letters. Yes, big buzz. Do this with PowerShell for me right now in a few seconds and show me the command, and I get you a smart price. Well, this is an addition that we just bring to the table for ESI. That was the short overview. We could also go back into our MMC UI and we could refresh that host. And we could refresh the storage array because we have done stuff outside of the ESI MMC. So the LUN test 1 eventually is not here. But if we do a refresh, he goes out and refreshes all the storage pools, and we can do the same for the host itself, and he populates the information from host to the storage pools, and everything is in. Yeah, I'm not sure if we should wait for this right now. Actually, I'm working with the beta code right now for the latest version 3.5, so some stuff might be a little bit slower than on the final because of debugging, but that's okay at this stage. If we go back into the LUNs, we should see a LUN named test1. It's here, LUN 23, 100 gig, that's the one we built. If we go to Agent J and he has refreshed his information, there must be a 100 gig LUN, test LUN 1, and it's called test1. Okay, here we are. That's all so far for the basic overview of what we can do with the EMC storage integrator.